Hello friends, a warm welcome to our next session on instrumentation and control in power plant industry. In today's session, we will discuss about the various types of temperature measuring devices used in a power plant. Before discussing the different types of temperature measuring instruments, it is important to understand why temperature measurement is so crucial in a power plant. Temperature directly impacts the efficiency, safety, and overall performance of the plant. The very first reason for temperature measurement is efficiency optimization or heat rate improvement. We know a power plant converts the chemical energy of fuel, maybe coal or gas, into thermal energy. This thermal energy is used in boilers to produce steam from water. Then this steam rotates the turbine blades. That is, the thermal energy is converted into kinetic energy. The turbine blades are connected to turbine shaft, and this turbine shaft is coupled to generator shaft, which further converts this into electrical energy. So we saw a lot of energy conversion is taking place with lots of energy losses also. So our ultimate aim is always to reduce these energy losses and to increase electrical energy output corresponding to the fuel burnt. Temperature measurement ensures that the thermal energy produced is efficiently converted into electrical power. Monitoring and controlling temperature in different stages of the power generation cycle help maintain optimal conditions for heat exchangers and energy conversion. Next reason is our equipment protection. Power plant components such as turbine and boiler operate under high pressure and temperature. Continuous temperature monitoring helps prevent overheating, ensuring the longevity and reliability of the critical equipments. For example, in case of high bearing or winding temperature, we have to protection trip our pumps to avoid their damage. Third reason is thermal stress analysis. Many components, especially those in steam turbines and boilers, are subject to thermal cycling. Accurate temperature measurement help in understanding and managing the thermal stresses and thus preventing the mechanical failure and therefore increases the life of equipments. Fourth reason is fuel combustion optimization. In, in a combustion process, maintaining the correct temperature is essential for efficient fuel combustion. Temperature measurement in combustion chambers help optimize fuel to air ratio, ensuring complete combustion and reducing emission. Next reason could be safety compliance. Power plant must adhere to strict safety regulations, and temperature monitoring is critical to ensuring compliance. Monitoring temperature helps prevent unsafe conditions such as overheating or excessive pressure, which could lead to equipment failure or accidents. Then our sixth reason is prevention of thermal runaway. Some processes in power plants are exothermic. Exothermic means they release heat. Without proper temperature control, these processes can lead to thermal runaway, causing uncontrolled temperature increase and potential damage to equipment. The seventh reason is condenser performance. Maintaining optimal temperature in condenser and cooling system enhances the efficiency of power generation cycle. Next reason is efficient heat exchangers. Basically, heat exchangers play a vital role in transferring thermal energy between different fluid streams. Temperature monitoring ensures the heat exchangers operate within specified temperature ranges, maximizing their effectiveness. And our next reason is environmental compliance. Power plants must adhere to environmental regulation regarding emission and cooling water discharge temperature. Temperature monitoring helps in controlling and mitigating the environmental impacts. And the last reason is operational control and diagnostics. Basically, real-time temperature data provides insight into the operational health of the plant. Anomalies in temperature pattern can be an indicative for potential issues, allowing for proactive maintenance and troubleshooting. So, in this slide, we discussed the temperature measurement in power plant is essential for maintaining efficient and safe operation, ensuring equipment integrity, and complying with regulatory standards. It is it is a critical aspect of overall plant performance and reliability. Clear? Moving to our next slide. So next slide is our main topic, that is the type of temperature measuring instruments used in power plant industry. In a power plant, we use various types of temperature measuring devices to monitor and control the temperature in different parts of the facility. Some of the basic temperature measuring devices commonly used in a power plant industry are: first one is thermocouple, next is RTD. RTD means resistance temperature detectors. Then third is infrared thermometers. Next, biometallic temperature gauges, gas thermometers, thermistors, fiber optic temperature sensors, thermal imaging cameras, and mercury in glass thermometer. So we will discuss all these temperature measuring devices one by one. Our first one is thermocouple. Thermocouple is a temperature measuring devices which is widely used in power plant for their simplicity and versatility. They consist of two wires, basically different wires, joined at both ends, and the voltage generated at the junction is proportional to the temperature difference between the two junctions. It operates on the Seebeck effect. Seebeck effect was given by this picture we can see. This is TJ Seebeck. Uh, It operates on Seebeck effect, which is the phenomena where a voltage is generated when two dissimilar metals are in contact and are exposed to a temperature gradient. And the voltage generated, although this voltage is very small in millivolts, this voltage produced is also called Seebeck voltage, is proportional to the temperature between this temperature difference between the two ends of the thermocouple. The two ends of thermocouple where the metals are joined form the hot end. One junction is called hot junction and second is called reference junction. Hot junction is basically the junction which is in actual contact with the temperature measurement. This junction is exposed to our process fluid, or to be more precise, not directly with the process fluid, but to protect the thermocouple, we use thermowells, which is in direct contact with the process fluid. Insertion type basically. And the other end is where the thermocouple wires are connected to a measuring instruments. This second junction is known as reference junction, or sometimes also called as cold junction. The temperature at this reference junction need to be known or compensated for actual temperature, accurate temperature measurement. Different combination of metal create various types of thermocouples, such as type K is our chromal aluminum, type J is iron constantan, and type T is copper constantan. The measurement range of these K type, J type, and T type thermocouples is also different. For example, our type K thermocouple is which is made from chromal and aluminum can be used for minus 200 degrees centigrade to 1260 centigrade, whereas this J type is suitable for 0 to 760 degrees centigrade, and it type T is best suited for minus 200 degrees centigrade to 370 degrees centigrade. Clear? Moving to our next type is RTD. RTDs are basically resistance temperature detectors. These RTDs are temperature sensors that operate on the principle of the change in electrical resistance with temperature. RTDs operate on the principle that electrical resistance of a metal changes in predictable and basically essentially linear and repeatable manner with change in temperature. So when we heat this in this figure, we can see we are checking the resistance across a copper wire, piece of copper wire. So without heat and with heat, the resistance is different. So RTDs have a positive temperature coefficient, that is their resistance increases with temperature. And most commonly used is platinum, Platinum is a common material for RTD, providing stable and accurate measurement. Generally, in a power plant, we use PT100 with a resistance of 100 ohms at 0 degree centigrade and 138.5 ohms at 100 degrees centigrade. This PT100 can be used for a range of minus 200 degrees centigrade to plus 850 degrees centigrade. These RTDs are also known for their high accuracy and stability over a wide temperature range. Basically, in a power plant for pump bearing winding temperature, we use these RTDs instead of thermocouples. For mainstream line temperature measurement, we are using thermocouples, while for equipment pumps, etc., we use RTDs. Our next type is infrared thermometers. Infrared thermometers measure temperature by detecting the infrared radiations emitted by an object. Every object emits infrared radiation. These infrared radiations are nothing but heat radiations corresponding to their body temperature. Infrared radiations are concentrated on this lens. In this picture, we can see this, there is an object, and these red lines are showing the infrared radiations. These are focused on a lens. Then this lens is concentrating these infrared radiation on a detector. This detector is called a thermopile. In simple sense, if we call this thermopile is nothing but a combination of multiple thermocouples. This thermopile converts the infrared radiation into electrical energy. So more is the infrared radiation, the stronger will be the electrical signals. That is, hotter is the body, stronger is the infrared radiation, and more powerful will be the electrical signal produced. Then this electrical signal is further sent to the processor, and a processor calibrates this electrical signal corresponding to the temperature range, and this temperature is finally displayed on the display indicator. Best part is they are non-contact devices and are often used in power plants for remote temperature measurement of equipments such as transformers or electrical panels, which are generally not supposed to be touched by hand. Next is bimetallic temperature gauges. Bimetallic temperature gauges consist of two different metals bonded together, which expand at different rates when heated. Uh, Please don't get confused with RTDs. RTDs are also two dissimilar metals, but in basically they operate on Seebeck effect that due to electrons flow, this if potential difference is generated, millivolts are generated. Here it is expansion of the metal itself. So two different metals are bonded together in bimetallic temperature gases, which expand at different rates when heated. The movement of the metal causes a mechanical displacement that is translated into temperature reading. Basically, there are two different types of bimetallic temperature gauges used in industries. In this picture, we can see this spiral shaped. So first one is spiral shaped and second one is helical shaped. And one more thing, these bimetallic thermometers are commonly used for local temperature monitoring, that is for local gauges in various power plants. These are not used for remote indication to our DC system. These are only for local indications, local gauges are there. The next type is gas thermometers. Here, gas thermometers measure temperature based on the change in volume or pressure of a gas with temperature. Here, instead of this glycerin or some other fluid, it is gas which is filled in these pipes, and then due to the temperature, this gas volume changes and or pressure changes, which makes this pointer to rotate, which gives an indication of temperature. Clear? Again, type of local gauge. They are suitable for high temperature application and are often used in specific areas of power plants where other sensors might be less effective. Coming to our next type, it is thermistors. Thermistors are temperature sensors that use the resistance temperature relationship of semiconductor materials. Till now we covered about metals. This one is basically designed by using semiconductors. So there are two types of thermistors. One is NTC, that is having negative temperature coefficient, means the resistance decreases with increase in temperature. In this graph we can see there are two types are shown. One is NTC and second is PTC. NTC is negative temperature coefficient and PTC is positive temperature coefficient. NTC means negative temperature coefficient means resistance decreases with temperature, while the PTC means resistance increases with temperature. Clear? Generally, NTC thermistors are most commonly used in temperature measurement, while the PTC thermistors are primarily used for circuit protection. They are highly sensitive to temperature changes and are often used in application where precision is crucial. However, as compared to our simple RTDs, the response time of these thermistors is non-linear, but thermistors have better precision. Coming to our next type, it is fiber optic temperature sensors. Fiber optic temperature sensors uses the principle of change in light transmission properties with temperature. In this figure, we can see that laser light emitted by the laser source is multiplexed into two lights using beam splitter. One is focused to the reference fiber using lens L1, while the second beam is focused to test fiber, which is measuring process environment. Thus, the beams are then focused on lens L2 and their interference pattern is plotted. Clear? Means one laser source, the emitted laser is basically split into two parts. One is going to lens L1 and second is going to lens L3. L1 is then focusing it through reference fiber and lens L3 is focusing through test fiber, which is in our actual process medium. Then there then the beams, their outlet side beams are then focused on lens L2 and then it is basically plotted on their interference pattern is plotted. Then the difference between the two interference pattern is due to the temperature of the medium the beam passed through in the test fiber. Thus, thus we can say this difference between the two interference pattern is calibrated to produce temperature indication. Clear? It supports wide temperature range of measurement from minus 10 degrees centigrade to plus 300 degrees centigrade. And the temperature sensing materials include GaAs, basically opsin gallium arsenide, then CDT, which is cadmium telluride, and Si, which is silicon oil. The opsin gallium arsenide offers better wavelength variation with temperature. So most commonly used material for this fiber optic temperature sensor is opsin gallium arsenide. Best part is this fiber optic temperature sensors are immune to electromagnetic interferences and can be used in challenging environments such as high voltage areas. Clear? Next type is thermal imaging cameras. Thermal imaging cameras basically captures the infrared radiation emitted by an object to create visual representation of temperature distribution. Again, we have two types of thermal imaging cameras. One is LWIR, which is for low temperature measurement between minus 500 degrees centigrade to 900 degrees centigrade. And our second type is NIR SWIR for higher temperature measurement, which ranges from 450 centigrade to 2450 degrees centigrade. They are valuable for identifying hot spots and anomalies in electrical systems and mechanical components. Clear? Coming to our last type is mercury in glass thermometer. Our These are less common today due to environmental concern. Mercury in glass thermometers were historically used for temperature measurement, and they basically consist of a glass tube with a mercury column, and this mercury column length changes with temperature. So in short, we can say the selection of a temperature measuring devices in a power plant depends on the factors such as temperature range, accuracy requirement, environmental conditions, and the specific applications within the facility. Often a combination of these devices is employed to ensure comprehensive temperature monitoring. So friends, this was all about types of temperature measuring devices. Hope I am able to clear the concept well. One request is your valuable feedback is most welcome. So please share your feedback in comment section. We will meet you in our next videos. Till then, stay safe, stay healthy, take care. Bye.